Hello. Yeah, I'm Gerard Espinas, and I'm here to present to you my course project. Build a model to predict the electrical energy output of a combined cycle power plant. Okay. So just give you a project background on this. The project in this project, we need to build a model to predict the electrical energy output of a combined cycle power plant. So, what do you mean combined power cycle power plant is a combination of different such as gas turbine, steam, and heat recovery steam generator source to generate power. So we have a set of almost 9,000 plus ho- hours of average ambient environmental reading from sensors at the different power plant. So in building the model, we need the data sets that could be downloaded from Google Storage, and the file name will be ccpp underscore data. It's in the form of CSV file. And as you review the file, you can notice the different columns such as temperature, pressure, humidity, vacuum, and the output energy. It's very important in building the models um, in predicting the power plant. Our project objective in building the model is that we need to determine the machine learning or the model to be used, identify the possible features to use in the model, and identify the different algorithm we might consider. And then next will be splitting the data uh, ta- into test set data and training set that data for the different model, and validate the performance of each model. And then later on, we need to choose the best model to predict the energy output. So I use Jupyter Notebook um, in running and validating the models. So it's in Python. So we analyze the different correlations of the different features versus the output energy, and you can see in the lower uh, portions of the image the different correlations value. In this case, it's a predicting the output power. So typically, it will be a regression analysis. So we choose three models for it. Will be linear regressions, decision tree regressions, random forest regressions, and in the previous slides, I mentioned about temperature, pressure, humidity, and vacuum um, uh, to build our model. And you can see the codes that I use for the different models to be used. Then for each model, we need to apply four four iterations. So means x1 consists of single feature AT. X2 will be applying two features AT and AP. X3 will be applying three features against the model AT, AP, RH, and X4. We're applying all the features in linear regressions. The same goes with decision tree regressions and random forest regressions, we apply x1, x2, x3, and x4. It's very important to split the data into training data and test data. We use 20% for the test data against the 80% training data. As you can see in the code here, for training x1, so meaning this is the code, so you can see that we split into uh, training data sets and test data sets. So it's for same with x2, x3, and x4. Then for linear regressions, we import the sklearn library from Python, and we applied the code for x1, x2, x3, and x4. So you can see that we import the linear regressions, and then we split test, and then we follow in predicting uh, the outcome versus the x1, x2, x3, x4 test data. In evaluating the performance of linear regressions for both x1, x2, and x3, and x4, so we apply the root mean squared error, uh, the r squared, and the mean absolute error. And you can see for x1 the different output. Next, we apply the same RMSE, R squared, and MAE to x2 for linear regressions, and you can see the output here. Then x3, we apply, you can see the output, and for x4, we apply again, and you can see the different outputs. So for decision tree, we import the decision tree regressor from sklearn, and then you can see we applied the decision tree class for x1, x2, x3, and x4. And then from random forest, we import from sklearn library the random forest regression class, and then apply x1, x2, x3, and x4. So upon getting all this, running all this code, then we get the summary tables here. And one of the criteria in selecting the best model, upon compiling a summary of all the regression class that we use, and the different features and the different performance parameter to validate the model, we can see that the lower the RMSE score, the better. The higher the R squared score, the better. The lower the MAE value, the better. So in this case, when we analyze it, the best model for predicting the power output for a combined power cycle plant is using the random forest regressions. That fits in the criteria just now we mentioned for the best fit model for this project. I hope you uh, can see appreciate the calculations and the preparations that I have done, and kindly review it. Thank you very much.